Hi everyone, let's solve today's daily challenge, that is eliminate maximum number of monsters. So in this question, it is said that you are playing a video game, right? Where you're defending your city from a group of n monsters. And here an array dist of size n is given to you, and dist of I is what? It is the initial distance in kilometers of the ith monster from the city. And then the monster walk towards the city at a constant speed, and the speed of each monster is given inside of another array of size n, and speed I is basically representing the speed of the ith monster in what? Kilometers per minute. So let's draw the situation. It's given to us. So this is your city, okay, and inside of the video game you're protecting your city. Now you're defending your city or protecting your city from whom? Monsters, right? So let's say these are some monsters here. Now we are given an array called dist. Inside of this dist array, so here we have four monsters. So we are given four distance inside this dist array. Let's take them as 2, 4, 3, and let's say 2 again. Okay. These are the distances given to us. And okay, let's draw these distance. Let's say this is 2 kilometer. This is 2 kilometer again. This is 4 kilometer. This is 3 kilometer. Okay, and then we are also given a speed array, right? Inside this speed array we are being told that these monsters are traveling towards the city at a constant speed, right? So that speed is given inside of what? The speed array. So let's take the speeds as 1 2 and 1 and 2. Okay, so corresponding to this particular distance the speed is 1, so that is for 2 kilometers the monster is traveling towards the city at 1 kilometer per minute, right? And then with 4 distance the speed is going to be 2, so this monster is traveling at 2 kilometer, okay, per minute. Then here the monster with this 3 kilometer distance is traveling at 1 kilometer per minute towards the city, and this monster with 2 kilometer distance is traveling at speed 2 kilometer per minute towards the city. Now, so now we know the situation, what's happening. Now, what is it that we want to calculate here, right? So, we are given a weapon that once fully charged can eliminate a single monster. However, the weapon takes 1 minute to charge, and the weapon is fully charged at the very start. Okay, so you lose when any monster reaches your city. If a monster reaches the city at the exact moment the weapon is fully charged, it counts as a loss and the game ends before you can use your weapon. So we need to return the maximum number of monsters that you can eliminate before you lose, or n if you can eliminate all the monsters before they reach the city, right? So what we have to basically do is we have a weapon, okay? And right, so you are standing here and you have a gun, let's say that is your weapon, and you can kill these monsters, right? But the problem is after you kill one monster, let's say you kill this particular monster here, after you kill that monster your gun takes 1 minute, 1 minute to fully charge and ready to kill another monster. Now what we need to tell is the maximum number of monsters that we can kill, right? Or we can kill all monsters also, but that depends on a particular input case that is given to us, right? So now let us see how we are going to solve this question. So I hope the question is clear to you, right? So you have a gun, you have some monsters, you are given their distance and speeds, and you need to tell the maximum number of monsters that you can kill. Now, initially you might think that we may take the distances, right, and sort these distances, and according to the distances, whichever monster is, let's say this is nearer, right, to the city, that is 2 kilometers. The smallest distance is 2 among this array. So you'll first kill this monster or this monster, right? And then you will be killing the monster with 3 kilometer distance and then 4 kilometer distance, right? So the problem with that is, let's say initially he is here, okay, so you kill this monster. Let's say some other monster, see this monster is only traveling at 1 kilometer per minute and this monster is traveling at 2 kilometer per minute. That is, at t is equal to 0, this is the situation, at t is equal to 1 this monster will be here but this monster will be at your city, right? So if you decide to kill this monster first, then what will happen? This monster will come and destroy the city. But can we do better than that? Yes. What we will do is we will kill this monster first because he's traveling at a greater speed, right? And then we will kill this particular monster because at t is equal to 1 he will be here. And as soon as you kill this monster, between 0 to 1 minute, you will charge your gun, your weapon, and then you will kill this monster, right? So you have killed two monsters up to now. And then this monster would have traveled up to here, that is half the distance, because he's traveling at 2 kilometer per minute. And this monster would have traveled this distance, that is 2 kilometers from here, right? So which monster will you kill next? Right, so you can choose to kill this monster or either this monster, right? So the answer in this case is going to be 3, right? So we notice that alone the distance is not going to help us, so we need to have a better parameter than that, and the better parameter would be nothing but time itself, right? So how will we calculate time? Time can be calculated by distance by speed, right? So that is the way we calculate time. So we calculate time is equal to distance by speed, and according to this time parameter, right, whichever monster. So see, what we are basically calculating is how much time this monster, how many minutes this monster is going to take to reach the city and destroy the city, right? So according to time, first we'll calculate the time in some container or data structure. We'll store it somewhere and then we'll sort it, right? We'll sort it, and according to this time, right, whichever value is the lowest, right, we will keep killing these monsters this way, right? So this is how we can maximize the number of monsters killed. So now I hope you have understood how we will be going to solve this question. Now another thing to note here is that although the distance and speed are going to be integers, but when you calculate time, it can be a fractional value. So what to do in that case, right? So do we need to include fractions here? Not at all. So what we are going to do is, let's consider this test case here. So here we are given the speeds are 1, 1, 2, 3. This is the distance, and the speeds are 1, 1, 1. Okay, this is not a good, okay, this one let's take. We have distances as 3, 2, 4, and the speeds given to us is 5, 3, 2. Speed given to us is 5, 3, 2. All right. Now let's draw the situation for this particular test case. This is your city. These are your monsters. And this is 3 kilometer distance. This one is 2 kilometers. And this one is 4 kilometer. And the monster with 3 kilometer is traveling at 5 kilometer per second speed. And this particular monster is traveling at what speed? 3 kilometer per minute. And then this monster is traveling at 2 kilometer per minute. This is the speed of these monsters. Now if you see, when we'll calculate the time, okay, the time required for this monster to reach to the city is 3 by 5. Okay, for this monster, that is 3 by 5 kilometer this monster will travel each minute. Okay, and this one is going to be 2 by 3, and this is going to be 4 by 2, that is 2, right? Now in this situation, what we are going to do, right? So even though this is a fractional value, if I take the seal of this, right, that is, if I divide 3 by 5, what am I going to get? Integer value is 0. But if I take the seal of it, of this in fractional value 3 by 5, what am I going to get? I'm going to get 1, right? So I can say that within this particular time, this monster will certainly be killed, right? Because even though he's traveling fractional distance each time, that is 3 by 5, but we are taking 1 minute to charge the gun, right? So basically, if the monster is killed here, right, so that is going to take 1 minute, right? So that is why if I consider the seal, I know I will certainly kill this monster. So that is what we are going to do. In case we are getting fractional values, so we are going to store the seal of this fractional value time, right, inside of my time container that I'm going to make, right? So I hope things are clear. Now let us go ahead and try to implement it. Another thing, that here instead of sorting, right, instead of taking an array and sorting it, I'm going to take a priority queue or a min heap, right? So inside of the min heap, what I'm going to do is I'm going to take, first I'll be storing these times inside of the min heap, and then I'll keep popping, and up to what time I have to keep popping, until my time, right, is less than, right, the time, this t is actually whatever time is running. So we are at 0 1 2 3, so this is the time that is running, right? So it is increased after 1 minute, right? So incremented after 1 minute, incremented after 1 minute, incremented after 1 minute. So this t, if this t is less, right, then the time that requires the monsters to reach, then I can kill that monster, right? And I have time to kill another monster as well. So this is what we are going to do, and we'll keep popping the values from min heap until this condition is true, that is time of I, or the top of the priority queue, or the min heap, right? If this condition is not true, we will break out of the loop. Now let us go ahead and implement it. First here, what I'm going to do is I'm going to make my priority queue or min heap, right? This is how we make our min heap in C++, because by default the priority queue container is an STL container, and it is by default a max heap, right? So this is the syntax to create a min heap. Okay, so PQ I have created. This is my priority queue. Now the next thing that I have to take is this integer value t. That is, I am increasing the time, and I am checking for each and every minute. I'm going to check, right, if I can kill a monster, because after every minute my weapon is getting fully charged. So now let us go ahead and insert values in our priority queue. So what are we going to insert in our priority queue? We are going to insert distance by speed, that is the time required by monster to reach to the city, right? So for int I is equal to 0, I less than distance dot size I plus plus, and then inside of PQ, what am I going to push? Now other thing is that I cannot just push distance by speed. I have to see if it is a fractional value or if it is an integer value. If it is an integer value, I will simply put it, right? If it is not an integer value, I have to add 1 to it. That is, I have to take the seal. You can use the seal function, or you can also add 1 by checking if it is a fraction or not, right? So I'm going to check if this is a fraction value, modulo speed of I. If this is 0, right, then what I have to do, I have to store distance of I by speed of I inside of the priority queue. Otherwise, if this is a fractional value, what I have to do, I have to store distance of I divided by speed of I plus 1. That is the seal value of the fraction that I'm getting. So I'm going to do what? I'm going to store distance of I divided by speed of I plus 1. That is what I'm going to store. So my priority queue is now made. Now what I'm going to do, I'm going to iterate inside this priority queue, and I'm going to take the top element each time, and I'm going to check it against the time that I have, right? So if the time that is running and a monster is, is going to be killed after some more time, right? The monster should take more time than this t time to reach to the city. Only then the monster will be killed, right? So my condition is going to be, let's write pq dot empty. Either our priority queue will get empty, or we will break out of the loop before it gets empty. So the condition is t should be less than pq dot top, right? So the monster should always take more time to reach than the time that is we are currently at, the minute that we are currently at, right? Only then we'll be able to kill the monster. So in this case, I have to pop, right? Otherwise, break, and we'll also increase our time in each iteration. Okay, and after this I can simply return this t value, right? Because each minute I'm killing a monster, right? If I'm not able to kill, definitely after that all the values will be greater and I will not be able to protect the city, so I have to return the t value only. Okay, so this is accepted. So this is basically how we need to solve this question, right?